is Phagm, pronounced like phenomenon. I run a company called Nonfiction. I run it with my husband. My husband is not here. Today is actually our 17th anniversary. I know I did not go there yet at all. But he's in Chicago right now, but yeah, usually we do this talk together, but today it's just going to be me. So Nonfiction is a company that is 8 years old. And what we do is that we take science fiction and we make it real for the benefit of all, right? That sentence that you see up there is actually essentially my life purpose. Everything that I do in life, everything that I manifest is in alignment with that statement. And then there are many different disciplines that we practice as a studio. We practice strategy. What do we do? Why do we do it? Who do we do it for? Industrial design, which is the design of mass manufactured products. So I don't just design one thing, I design a million of one thing. Branding, how you present yourself and how understandable and desirable your brand is. Space architecture, I'm among people who actually know what that is, so that's cool. Engineering, different types of engineering that we practice or have partners in, mechanical engineering, electrical, software, etc. And then systems design, so here think about educational systems, transportation systems, even life support systems. What's very special about the work we do is why we do it and how we do it. So a lot of the times when we talk to designers, they're like, oh, here's a shape, and it's beautiful, people are going to buy it. It turns out nobody wants to buy it. And the reason for that is because they don't really take into account all of the disciplines necessary to make a product successful. You have to think about business, you have to think about the science behind it, you have to think about the technology that's going to be used by the people. You have to think about emotion through art. And to me, design by itself is quite useless. Design is, however, a great connector of things. And so we connect all of these things to create meaningful innovation. And in order to do that, I had to establish what we do as a company, and especially what we don't do as a company. So what we don't do is that we don't copycat other people's ideas. We don't go after, the cheap dollar of making products that everybody else is doing. So we exclusively do innovation that's never been done before, which is why we go specifically after university research labs. We go after startups. I was in San Francisco for 12 years until a month ago, and I'll tell you more about why I was in San Francisco. The second point about the type of work that we do is that every single one of our clients has to satisfy at least one of the 17 sustainable development goals put together by the UN. Right? We live in a time where, if you're not benefiting someone somewhere, some infrastructure, it's like why we do this. And then the third thing, which is very important, is path to execution and success. All of us, everywhere in the world, have fantastic ideas. We have very kind ideas, we have very noble ideas, but very few people want to actually do the work to execute them all the way. So that's something that's very specific to us. So one thing I have to explain every time I'm in front of people who are not in the space industry is that why space, right? The vast majority of the people out there will probably tell you, well, you spend so much money and effort and resources in space when there's so many problems on this planet. Well, it has a lot to do with innovation, right? Innovation is accelerated and is brought to space, and that's something that we do. And a lot of that innovation can actually come back to Earth to benefit all of us. Again, connecting to the 17 sustainable development goals. And there are many examples of that. I'm not going to go over all of them. You've probably heard it at least 5 times during this conference. But yeah, things that we use every day actually are developed from innovation that came from space. So what I'm going to do next is that I'm going to go after certain scenarios. Some of them are going to feel very familiar to you, and some of them are going to feel like, we're talking about astronauts. So the first thing I'd like for you to see is, so you see this astronaut in the spacesuit, and she has this helmet on with some communication devices on. And if you look at the communication device, it's this very simple, basic geometries. For those who do 3D, it looks like it was designed in 3 minutes in SolidWorks. And it hasn't evolved that much. But when you look at her face, everybody's face, we're all made of very complex geometries, fractals and high cheekbones and things like that. So why should we have basic geometries touching or near our faces or parts of the bodies. So here come human headphones. Human headphones came out about 5 years ago. They're the first on-ear headphones true wireless without a middle. The way they work is that they actually connect to each ear independently, and it's pretty incredible to be able to connect to each ear, because if you look at around the room, each of our ears, even between left and right, is completely different. There's some smaller, some bigger, some more sensitive, some taller than others, and it was very difficult to actually fit all of this on all of these ears, but we were able to do it. And create a critical system that allows you to do that. So that's actually an example of what I call natural design. Natural design takes direct inspiration from nature, and in this case of river rocks, and puts that natural geometry closer to the body, so we don't have to have those straight lines and perfect radii, large LED screens, and the things we used to. All of this was possible thanks to a lot of collaborations between teams. As you can imagine, fitting, the image is terrible here, fitting a lot of very complex components in an extremely organic geometry was very difficult. But that was possible because the mechanical engineers, the industrial designers, the software engineers, the acoustic engineers were all in the same room every day making decisions together. If I give you something, you have to give me something. It was literally 6 months of that. And after 6 months, we're able to come up with a geometry that actually works. But it's not only about the geometry when we talk about natural design. The interaction that you have with technology is also very important. So if in nature, if on our bodies we don't have buttons, why should we have buttons on our technology? So instead of changing the song or turning up the volume by pushing a button like you do on your phone, you actually just have to slide your finger up or down or forward or back. Another thing that this product does is that it translates in 11 languages as you walk down the street. And it has a lot of really cool things in it. So from an ergonomic standpoint, making sure that all of this work, all the work that we did wouldn't be possible without 3D printing. We 3D printed more than 700 prototypes to make that work. Because as I said earlier, ears come in all shapes and forms. So it's very, very complex to actually solve that problem. But we're able to do it by essentially 3D modeling during the day, and 3D printing all night long, assembling in the morning, and testing on subjects. We did that every day for 6 months, and it was actually really fun. I have boxes and boxes of those. Next, I want to talk about working out. All of you might know that working out in space is necessary, otherwise you're going to pay for it for a very long time. Bone loss, muscle mass loss, a lot of hormones going up and down and all that. So regulating all of that when working out, about 2.5 hours a day is essential, especially if you're going to stay in microgravity, let's say 1 a week. So this is pretty much what it looks like when you work out according to SS. Imagine having to do that for two hours every day for your whole mission. Motivation is going to be pretty low, but you have to do it, otherwise you're going to get very sick. So motivation in working out is something that all of us probably suffer from, right? We love to be very motivated to go to the gym and do all the sit-ups and this and that, but chocolate cake is pretty nice too. So what we did is that being in San Francisco, I get to work with really incredible world leaders in neuroscience. And in this particular case, we designed a device that stimulates the primary motor cortex. So this is a pair of headphones, and yes, it plays music, very bad music, but really the main function of it is to apply a little bit of electricity on top of your head. And that is actually where your primary motor cortex is. And what happens when you do that in a very specific way is that it helps your brain get into a state of flow much easier, right? So when, for example, when you start working out, when you start jogging, the first 5 minutes you're like, this is awful, I hate it. And after a while, you get in flow, where you're not even thinking about putting a foot in front of you, you just start enjoying it. So it's the same thing for athletes, and here you can see the USC team in cycling, actually using our product. And what's great is that when you think about athletes and the Olympics and things like that, for a long time, But today, the difference between a silver and gold medal is technology. Is how much time do you spend in your peak performance during training? That's going to guarantee, the best performance the big day. So one thing that I love to do is to take very complex, very niche, very expensive technology and make it use training affordable. So for a long time, this kind of technology wasn't available for like $10,000, $20,000 for a headset that looked like something awful, and obviously not everybody can afford it. Athletes don't care, they'll do anything to shut off like hundredth of a second. But what we did is that we helped this company not only design it, but also reduce the cost to $350 a pair, so you can actually afford that. A lot of people ask me why they could buy it. Unfortunately, they got acquired. Fortunately, they got acquired, so you can't buy it anymore. They got acquired by a neuroscience company in Sweden called Flow Neuroscience, which focuses on depression. Next, I want to talk about sleep. So all of us spend a third of our lives sleeping, hopefully. And sleeping in space can be a little problematic, right? Especially when you're in Leo here, you're experiencing 16 sunrises and sunsets a day. There's like noise and no privacy and lights everywhere, like things like making really disturbing your sleep a lot. And on top of that, you don't have the comfort of gravity pushing you against the mattress, right? So this is pretty much how you sleep in space. And then there's some astronauts that believe that they have the best sleep of their life because nobody's bothering them. Say a large majority of them are actually not getting to sleep in the best sleep. So again, working in the Bay Area with the greatest neuroscientists, we worked with UC Berkeley this time, and basically what they found out is that there's a very specific pattern of brain waves that happen in the state of drowsiness, which is about 15 minutes before bed. And then during these 15 minutes, your brain is kind of following these patterns, and it's preparing your brain for sleep. And sleep essentially is like multiple stages of brainwave patterns. We're going to call it N1, N2, N3, and N3. So you go through these 4 phases 4 to 5 times a night. That's why about 7.5 hours of sleep is actually optimal. Obviously, it's different for everyone. But what's really cool about this is that using electrical stimulation of the prefrontal cortex, you can actually just wear this thing for 15 minutes before bed. Here you go to see the model, just take off the top, but if you take off the entire thing and sleep with nothing on your head, it still works because it's only for 15 minutes. And then the next morning you should be waking up pretty refreshed. A lot of people are like, oh, you use a lot of like solutions to like sleep better. Like I wake up early. Everybody wakes up early. Like the best time to figure out if you have a good night's sleep is actually around 9 a.m. the next day. If you're very focused and you're able to have like calm conversations with the people around you, you should be able to. So yeah, so this type of technology, again, applying a lot of natural design here. So you see some reference to mountain silhouettes, to rivers, and things like that. So everything that's around us that creates this beautiful harmony with nature is something that we want to integrate all of it. So one of our employees, who's 70 plus years old, was a lifelong insomnia. She could not sleep more than 3 or 4 hours a night. Was in drugs all the time. She was well known among all her friends as being the one who was drunk. And she became a big tester for this product. And on night 2, she was able to get almost 8 hours of sleep. Not only that, she was able to get an hour and a half of direct sleep and an hour and a half of sleep, which is essential sleep, right? And she's been able to keep that every night that she's using this. So it's pretty cool to have access to this. And so yeah, again, in terms of price, this is I think $300 in kilowatts. All right, so now we're going to talk about healthcare in space, which is what this little group here and some people around are very interested in. So, diagnosis can be pretty tricky when you don't have like all the equipment and you can't really hold people or shoot like massive MRI machines or anything like that. So yeah, this is what it looks like up there right now. expensive return flight. But the one thing that's in common between astronauts and a lot of people in the world is access to specialty care, right? A lot of millions and millions of people, not billions of people, live very far away. And these hospitals that may be closer to them might not have the specialty. So diagnosis might take a long time if they ever get it, and it might be too late by that time. So we work with this company called NDRX. And what they do is that they want to make telehealth diagnosis available to everyone at super cost and from anywhere. And so what they do is that they create robots you can swallow. Obviously, this is not what you swallow. This is the first. This is the first prototype, and it's basically a bunch of like medical device engineers and aerospace engineers working together. And I love these two worlds. Usually don't work together. So on one side you have a camera with a light, and on the other side you have propellers. So imagine this reduced to a size. At this point, it's about 10 millimeters in diameter. It's still big, but it's swallowable. And basically, what you do is that you swallow it, and there's some commands in there that can be wirelessly connected to a game controller. So a doctor on the other side of the planet can actually control a little robot going into your stomach and see if you have an ulcer or stomach cancer or whatever. So it's pretty incredible to work on technology like this. I mean, it's like straight up science fiction. And I'm going to show you a video that tells you about the origins of all of this.
The inspiration actually began earlier in life. Let's see, later space, you just sort of assume when you're young, if you see stuff like that, that it's real in some way, that it will be real in some way. The question we ask is, what is the response into is kind of beginning to become real. What you see right here is kind of where we are right now. And what does it gonna look like in the future? Like it's smaller. You know, maybe it could be like the 2001 Space Pod. What happens there? A lot is now like micro-sized. It's in your brain. And we might be able to catch things like cancers like tens of years, 40 microwaves cancer. So here's your future of telemedicine.
All right, isn't that cool? So about, I think, 32 robots have been swallowed so far, and if you ask me about how to get rid of it, you look it up. All right, next is about visibility. So here you can see a picture from the Apollo mission, and I would like for you to notice the shadows. So because the moon doesn't have an atmosphere, the shadows are quite stark, right? It's going to be bright regulars, or like blackness. And that's fine, if you have a small spacecraft like this and you're not going very far, but visibility in environments that are very dark like this can be very difficult and dangerous. And I'm sure there are some situations when we do analogs where you have to walk out in the dark and you're like, oh, I don't know, I can't really see, especially in these spacesuits that have very bad visibility looking down. So one scenario where it's very useful to solve that problem is with firefighters. So firefighters have to walk into burning buildings and then save humans and puppies. And the thing is, there's smoke everywhere, right? And that's not really what you see in Hollywood movies. They're like, oh, it's big flames and they walk out, it's easy. But visibility is absolute trash the entire time. And so one thing that we wanted to do is create edge detection, real-time edge detection on everything in the burning building. And that's very useful because you, as a firefighter, you need to know where the walls are, where the ceilings are, what's burning up, where the people are, where the puppy unit is in the middle, right? It's pretty important. So another thing that we need to do is also adapt our technology to the existing oxygen mask system that firefighters actually have. So on the outside, you have a thermal camera that sees what it needs to see. And on the inside, you have an AR rig that gives you that edge detection that I'm talking about. So this is the difference. On the left, this is what
regular vision gives you, so you can't see much. But on the right side, you can actually see your colleagues walking the room, the edges of stairs and walls and things like that. So it's pretty incredible. So working like this, again, a lot of 3D printing, a lot of prototyping, because these firefighters usually wear like 2 layers of gloves, they have like 90 pounds kind of equipment they have to carry. We had to make sure that this equipment not only worked, but also worked if it did work, right? If the battery went out or something, the system was overheated and you couldn't see through it, and it didn't work, you could still actually use the rest of the equipment to save lives and not interrupt your job. So we talked a lot about Earth at this point, and now we're going to jump to space. So this is what the International Space Station looks like. Super great interior design. Very peaceful to be there. I don't know about you, but you have to pay a lot of money to go there. And I'm not even talking about smell and all the discomfort that come with it. But yeah, it's a lot going on up there. There's an estimated 100,000 lost objects over the ISS. It's insane. And you know, not only crazy but also dangerous. So really, my foray in the world of space has to do with making it more human, because I'm gonna, you know, I look at images like I just showed, and I'm like, okay, not many people are going to feel welcome or be comfortable in an environment that looks like it was all based on function. So, you know, integrating kind of principles of design, things related to aesthetics, things related to value, things related to comfort, and ergonomics are going to be so incredibly important. And so, after doing a few years of work with that, we got to win a pretty incredible program, which is to outfit the ninth module from Sciences. So that's cool. So this is the last one-to-one scale module that was exploded at Washington Space Center in Huntsville, Alabama. So it's quite big. It's 9 meters in diameter, and it's designed to support 4 to 10 astronauts. And this module that we were in charge of designing is specifically designed for scientists. So scientists who are not necessarily professional astronauts will go up there and do their research on biotech, on growing crystals, whatever they're doing, and then living there. And they might be living there with their colleagues, and they might be living there with competing companies. So we had to think about all of that. So we're in charge of designing what's going on inside. And I can't go much into details about what it is, but yeah, so there's areas where you would do all of your science. There are common areas, there are private areas as well. But I can show you some like super early drawings. It doesn't even look like this anymore. But it gives you an idea of like how we think about things, right? Like the softness of walls, the type of materials that we're using. Not everything is rectilinear. Not everything is stark white and gray and blue. Everything has a little bit of a sensory kind of like conditioning to it. And again, I talked earlier about all the lost objects. Is there a way to actually rethink how we organize things in space so we know exactly where we are and we can find them even though we haven't touched that tool for the last 10 years? Same thing working out. I showed you earlier a picture of how it is to work out in space. Why can't we use very common technology, AR, VR, projection mapping, haptics, to make working out more something of an escape, or something that's actually pleasant on your physical body as much as your mental state. And then contemplation, right? Every single astronaut who's been around the Earth will tell you the most incredible thing to do is to stare at the Earth all day. So is there a way to do it in a way that feels like you're actually floating in space while looking back at the Earth and forgetting for a moment that you're in a tiny tin can? Well, one big problem that's happening in space has to do with food, right? You see a lot of articles and a lot of development having to do with propulsion, with launching, with 3D manufacturing of organisms, and that. There's a lot of really cool things going on there. But not that much is actually happening in the realm right now is not really appetizing, right? You can see a lot of like ready-to-eat food, which is kind of like used in the military as well. There's some shrimp here, you see on the left, which is terrible. It's very popular in space, but it's a lot of junk food if you really look at it, right? And another very common food in space is freeze-dried food. So look at this like very appetizing bag of spinach and that recycled water, which is so yeah, so you know, we had really food like this. That must be fun for about 2 days, and then on month 4 you want to murder someone. So yeah, so that's not that great for that long. So that's why the Centennial Challenges at NASA actually put together a challenge called the Space Food Challenge a couple of years ago. So that's a collaboration between NASA, the Canadian Space Agency, and then the Methuselah Foundation. So Methuselah Foundation is a foundation that focuses on longevity, right? Trying to find biomarkers and things like this that can actually extend life, especially healthy life in humans on Earth and in space. So what we did is that we decided to design, you know, the interior of a crew transport model, perhaps that would go to Mars, and design a kitchen for it, right? And even the language that I'm using, right? This is not a galley. This is not like, you know, ready to eat food. We're thinking about a kitchen or a garden. And at some point we had to build all of this. So build a system that actually functioned. So on the left side you can see there's like a garden with an aeroponic system where you can grow some greens. You know, when you interview some astronauts, you know, like if you ask them, you know, what do you miss the most when you come back to Earth, some of them will tell you the crunch of the salad. Because, you know, again, that goo that came out of the bag, no crunch in that. On the right side, at the bottom, we built a microalgae bioreactor. So microalgae has been shown to like be quite protective of cells, which can be useful for stressors that we experience in space, whether it's radiation or microgravity or, you know, being in space is stressful as well. The thing we learned about microalgae is that they're very easy to kill. We killed, I think, 30 colonies. Yeah, that's really hard. And that was on Earth, so I can't even imagine how difficult it is to do in space. But yeah, it was pretty cool to like grow some plants that actually look appetizing. And plants, not only are they, you know, good to eat and bring a lot of variety and fresh food in the diet, but also it's nice to be around a garden, something that goes leading to care of, that also supports your mental stability. And so, I don't know if you've ever eaten or tasted meat, but it tastes fire. And it smells horrible. So what we did in our studio is that we came up with a bunch of recipes, some sweet, some sour, some savory, some very unappetizing as well. And then we mixed them up and came up with recipes and started creating those balls that, you know, you can keep for like 2 or 3 days. And they're quite appetizing, they're very filling, and you know, it's a way to like basically put some good nutrients in your body in a more pleasant way. And of course, the space barbecue. So what we noticed, a lot of cultures in the world, you know, when they have a celebration, a grilled protein is usually what's happening in the table. You know, Christmas or Thanksgiving or you know, holidays of that sort. Unfortunately, you know, open fire is for everyone in space. So instead of doing that, what we did is that we took freeze-dried proteins here in chicken. We covered it with carbohydrates, and instead of applying fire, like we usually do a barbecue, we actually applied a grilled patterns using lasers. And I know it sounds weird, but it was actually good. The last project has to do with energy. And this one is very close to my heart because I was just there like 5 days ago. So there's a concept from the 1960s that talked about space solar energy. So basically you have an array of solar panels around the Earth and collecting solar energy without the filtering of the Earth's atmosphere, so higher concentration, and then you would beam down that energy down to Earth using microwave and then distribute it all out. Now, you know, there's some experiments being done right now in, at Caltech, US Air Force and all that. I'll let them do all of that work, but I want you to think about what happens in that last mile. What happens once energy is on Earth? Like, how does it reach the people who don't have access to energy? And it's kind of hard for us to understand that there are a lot of countries in the world that have never been through an industrial revolution. So, having a grid, having reliable power is just not a thing there. And you can't really see the title here, but essentially what we're doing is that we're creating an ecosystem for villagers in sub-Saharan Africa, in villages, to have access to renewable energy. So this is a picture that I took about a week and a half ago in Nigeria. Drove 5 hours away from Lagos in a essentially presidential convoy with like armed security. It was intense. And we fabricated this. This is the first of 500 kiosks that are basically, you have 2 workers working in them. And these kiosks are covered in solar panels. And inside you have inverters that basically take that solar energy and it transfers it to these batteries. So batteries are the hexagonal shapes that we see these ladies carry. And so we're actually there to see the first customer do this one. So you can see on the left side is how we do it. So these ladies who work in these kiosks actually use their own cell phone to swap the batteries. So you have customers laying up and they just pick it up. So this we're able to bring it down to 50 cents per week, and the batteries to be swapped infinitely during that week. You can see my face on the right side, extremely hot, extremely exhausted, but very happy that all the batteries are available to all these people. Another thing that we wanted to do with this project was manufacturing in Africa. So I spent 20 years manufacturing in China, manufacturing in the US, especially for medical devices. And manufacturing in Africa sounded very daunting because I'm like, standards are different there, right? I went to the factory and I looked around and I'm like, that's a factory. But you do what you can, and the reason why you want to manufacture in Africa is when you think about it, a lot of natural resources like wood and metal and lithium and things like this actually come from Africa, and they're often shipped all the way to Asia to be processed and manufactured, and then they're shipped to us in the US for consumption. So all of that travel is extremely terrible for the environment for all the reasons that we know. And on top of that, it's taking jobs and skills away from the people who need it the most. So we're manufacturing these in Lagos, in the city of Lagos. And we actually employ engineers there. And so this is actually the first prototype. It actually looks pretty much exactly like what we designed. It's pretty incredible to be part of all this. So right now, we just installed these in Nigeria. Before that, we were in Tanzania, still over there. In the next couple of years, we will install them in Uganda and in Rwanda. So hopefully, in the next few years, the entire continent will be full of these renewable energy batteries. So if you like what you heard from me today, there's a lot more. Like what I showed you is like 5% of what we did. So you can, we actually produce a video series called Future. There's a QR code on the top for your convenience. About 50 episodes, and very transparent about how we do things, how we think about design, how we make decisions. Because I'm not here to hide it from you and force you to you need to do it. You can try to do the same. What I want to do is for design to be less intimidating, right? A lot of people think of design as this discipline that's only highly educated or people coming from certain places in the world can actually afford. But design is everywhere. Making decisions is design. Making human decisions is design. And I encourage all of you to have at least one designer, one architect, one creative sort in your team, because they know how to take extremely complex problems and then turn them into products that everybody loves to use. Thank you very much.
2 minutes for questions. Right,
Paula?
just go.
Could you talk about how you find these clients to work with? Are they contacting you? How do you choose what products to take on?
Yeah. So our company is about 8 years old now, and we're at a point where the clients come to us because we've built a reputation of knowing how to like solve these complex problems, and they're very interested in being part of this like whole ecosystem of solutions that we're putting together. So the fact that we're solving problems globally and also off planet is very exciting to people. But in the early years, we ran our company kind of like as a classic industrial design firm, right? I designed a lot of computers, a lot of phones, a lot of speakers, whatever, and that got boring. So the day I actually found that sentence that was presented at the beginning, we turn science fiction into reality for the future. That's when a lot of the clients started shifting towards that mission, right? And sometimes we have some clients that don't know how to develop that mission, so we help them do it.
How many is the team?
We are surprisingly only 8. Yeah, so this year I just came back from Nigeria, as I said earlier. I'm actually spending an entire year traveling the world. Next I'm going to Indonesia, spending a month in each country because I'm trying to open a second office in a different country. The reason for that is because we've done a lot of made in USA or Silicon Valley based technology, and I'm interested in introducing more cultures and more different ways of